Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hafiza binti Bashruddin. My supervisor is Melissa binti Zulkifli. Today I'm going to present my final year project, which is Malay Festive season for recognition for the calorie detection system. Yes. For the chapter 1, I'm going to explain a little bit about the introduction. For the background of the study, food recognition system is a system that able to identify the type of food in an image captured by the user. The available choices for Malaysian foods are still restricted in some of the existing calorie estimation systems. Currently, there is no existing commercialized food recognition system that could recognize Malaysian festive season foods with just a snap of photo. This research focused on developing a system prototype to perform the recognition of some Malays common food, especially during Hari Raya. As we know that Hari Raya is one of the biggest festive season and the most celebrated season in Malaysia. My objective for this system is to implement color feature extraction methods for the food images. Next is to implement the SPM algorithms to support vector vision to classify the food images, and the last one is to determine the calorie estimation of the recognized food images. Next, I'm going to proceed with the literature review. For the project overview, the domain of this project is about the food recognition for the calorie estimation system. This project gives a deep research on how the food recognition is performed by using the image processing, which involves the usage of the image feature extraction and also image classification. As we know that in several studies that color feature has been used widely as an important feature in the food recognition during the image representation process. According to some studies, SVM is the most frequent techniques that not only used for the image classification but also for the pattern recognition purpose, speech data, emotion, and other such data classes. The chosen feature and techniques for this project is by generating the color of food image will be implemented as the main method for the feature extraction, and SVM will be used as the classifier in this prototype system. The combination of between these two, which is the color for the feature extraction and SVM, has not been yet discovered. Therefore, this project expects to find out the outcome between these two combinations. Next is the comparison of related works. There are four main authors for this reference for this system. The first one is by Reddy, which use CNN as the features as the extraction techniques and CNN for the classification. Next is he and others use texture features and location features and use classification super recognition. Next is the Cesino and others. They were using the extraction technique, which is combined backs of color features and texture features, and the classification is super recognition also. And the last one is the Muhammad and others. The extraction technique is the color histogram, and the classification is the artificial neural network. Next is the methodology for this research. In this project, it consists of 6 stages for the research methodology. The first one is the image acquisition, image processing, feature extraction, classification, training, and the last one is testing. For the image acquisition, Malay festive foods images are used as mainly, especially those food that usually served during the Hari Raya. It will be used as the data set for this research. 5 types of common food that have been identified for the dataset, so which are the melanin, bahulu, ketupat, lemang, and the tart nana. So the total original of 10 images per category is retrieved from the open sources, which is Google Images, in the form of JPG format. So bringing all this total together, 15 images that will be used for the training process. So for the testing process, total of 8 images per category, which sums the total to about 40 images. So next is the more elaboration image preprocessing. So the images used in the testing is not the same images that used in training, as this is important for the validity purposes. So all the images come with different angle and lighting. So, but for the color, shape, and edge and texture are different between one another. So for the training purposes, so image cleaning will be performed by removing the background of the images and left it with only with the white clean background. This is important to achieve a better result during pre-processing process later. So next is the image pre-processing. So pre-processing technique will be used in this research contains a set of sequential operations, including this prescribe the image size, image rotation, conversion of RGB images to grayscale images and to binary images. So a binary image then will be converted to the complement image. Then the noise of the image will be reduced to improve the segmentation of the image, and the output will be the result of segmentation that is needed for the feature extraction. So during this pre-processing, there will be a comparison being performed. So the comparison is the rotation between the data sets. So the images with different rotation are being evaluated with feature extraction technique to examine the robustness of the feature extraction adopted, which will bring the total training dataset about 200. Yeah, with three kind of factors rotation, which are 90 degrees, 180 degrees, and the last one is 270 degrees. So the next step is feature extraction. So colors, as you know that colors plays an important role in differentiating the type of the food. So therefore, the color extraction of a RGB image is performed during this phase. So the color of the input images from the pre-processing will be extracted individually. So this color this method will extract the red, green, and blue RGB to perform the each color channel from the image, and as a result, the 3 2D matrices is formed. So the next step is the support recognition classification. So the classification learner app in Malay has been used to train the models for classifying the image data. So despite of more than 3 classes of food are used in the research, so a normal SVM can't be used. So the fit multi-class model will be used to classify the type of food, which called the classification ECOC. So this ECOC is basically an error correcting output codes multi-class learning classifier that composed of the SVM binary learners. So the next step is the training model. So it is very necessary to train the model to recognize and understand the various patterns, rules, and the features. So the training images used for training is about 80%, which equals to 200 images, which through the rotation. So we'll be going up with total 200 with the original and rotation image, and 50 images which consists on the original for the comparison. So for this training, so the accuracy of the training model will also be tested in this phase to ensure that the training is well performed. So the last one is the testing model. So once the training model has been developed using the ECOC, it then will test the model. So the accuracy of the model will be tested in this phase, which will be done by providing with a separate dataset for the testing. So it is important to basically test the model since it evaluates the percentage accuracy of the model in accordance with the requirement of this project.
First, I'm going to show you my training code. So this is my training source code. So basically, it will read the training dataset, which consists of 200 images, and it will be classified using the COC, which is part of SVM, and then it will go through the training target output. So the total accuracy for this training is 94%. Next, I'm going to show you how the pre-processing and PCI extraction are implemented using the graphic user interface. So you can just click open image to open any type of image for the training. And then click on the segmentation to segment the image, and the segmentation image will be displayed. And to extract the color feature, just click on the picture extraction button here, and then the information about the RGB for the image will be displayed in terms of RGB, which is red, green, and also blue. And then it will classify what kind of food it is, so which is Himalayan. So if I want to see how the segmentation and picture extraction works for another type of food, please click the new food item. So this is the result of the segmentation, and this is the result of the color picture extraction. And then the classification is Pahulu. So here I have run my code for the testing. So this is the target output for the testing. So there are 14 dataset images. So it will basically load the model from the training classification. So it will load the MDL and it will test the testing dataset. So here I'm getting the testing accuracy is 82.5%. So next, I'm going to run the graphic user interface. So basically this is my graphic user interface. So user can upload the image of the food by clicking on this add item button, and it will be redirected to the dataset. So here I'm choosing the testing dataset. So I'm going to test just one of the item, and then it will detect the name, which is Emma London, and the calorie per piece, which is 110. So user can also add quantity of the food. Let's say I add 2 quantity, and click save to enter the information, and it will calculate it automatically. So this is the total calorie, which is 220. User also can add another food. And then the new food name will be displayed, which is bahulu, and the calorie is 72 calorie per piece, and they can just click on the quantity, let's say 3, and the newest item will be added. So let's try another one, food. So the newest item will be calculated, and it will calculate the total calorie, which is 506, even though the input are incorrect.
So the first one is by using the original data set, and the next one is by using the original and also the various rotation data sets. So for the original, the percentage obtained is about 90%, which the number of correct image is 45 and the number of incorrect image is 5. So for the original and various rotation, so the percentage is about 94%, where the number of correct image is 188 and the number of incorrect image is 12. So from the training result, it can conclude that the type of the training dataset that undergoes during the image preprocessing and feature extraction influence the training accuracy. So their percentage of using with the original training datasets is basically a little bit lower compared to the mixture of original with the various rotation training dataset, which apparently will affect the testing results. So the next result is the system testing result. So overall, there will be 8 images that will be tested per category. So as you can see right here, that the total correct percentage for the amylanin is 100%, while for the bahulu, ketupat palas, and lemang is 87.5, and their type minus is only 50%, which brings the total overall correct percentage is the 82.5%. So this is based on the wrong and the correct recognition. So in conclusion, the most accurate recognition is performed by the amylanin. So it can be concluded that the color of amylanin is contrast and contradict compared to other colors in the images. So, however, the incorrect recognition mostly being categorized as ketupat palas, as most of the foods are confused with the colors distribution of ketupat palas during training process, which is not consistent. So basically, the data set for the ketupat palas, the color is quite different. Like it has a very different color between one another. So next is the chapter 5, the discussion and also the conclusion. So there are also problems and limitations from this research. So the first limitation is the small data set for the food images. So as you can see, this project only uses the total of 80 images for each type of food, which is quite small of number. So this is because of the limited food images, since most of the food is not globally known and only consumed by Malaysians. So next is the problem with the other necessary objects that are still visible in the image, which has distorted the recognition, even though the image scan has been performed on the dataset. So, recommendation for the future work. So, since the prototype itself needs a large training set, so images from the public resources such as Google Images are not unreliable, as most of the images are not constant in terms of the angles and also the background. So, therefore, the suggestion of doing a collaboration can be made with the online community by uploading the food images based on the requirements. So the dataset then can be organized and made to public like any other food database available on the internet. So next recommendation is beside the colors that differentiate the foods, other factors such as shape and texture also can be considered in the future, as they play an important role in distinguishing the type of the food. So therefore, shape, texture, and the color feature extraction should be combined together, to increase the accuracy of the training dataset, so that the better result can be achieved. So for the conclusion, so the food recognition in this research has involved two major pieces, which are the feature extraction and classification, that are quite challenging in the field of the image processing. So, since there is no general feature extraction method that is available for all type of images, so an experiment, of course, is needed to be conducted to determine the suitable methods for the food images. Therefore, an investigation of PCOC classification and color feature extraction have been implemented to perform the recognition on the food. I think that's all from me. Thank you.